Chapter 10 is about all things circular. So we're going to start off our first lesson looking at circles and circumference. You'll learn to identify and use parts of a circle and solve problems involving the circumference of a circle. How far does a carousel animal travel in one rotation? The largest carousel in the world, still in operation, is located in Spring Green, Wisconsin. It weighs 35 tons and contains 260 animals, none of which is a horse. The rim of the carousel base is a circle. The width or diameter of the circle is 80 feet. The distance that one of the animals on the outer edge travels can be determined by special segments in a circle. A circle is defined as a set or locus of all points in a plane equidistant from a given point called the center of the circle. A circle is usually named by its center point. The figure below shows Circle C, which can be written as Circle C. Several special segments in Circle C are also shown. Any segment within points that are on the circle is called a chord. So this would be read chord AF. This is chord BE. A special chord that passes through the center is called a diameter of the circle. So segment BE is a diameter. Any segment within points that are the center and a point on the circle is a radius. So segment CD, segment CB, and segment CE are all radii of the circle. Note that the diameter BE is made up of collinear radii, CB and CE. And I kind of threw in the word radii there. The plural of radius is radii. The term radius can mean a segment or the measure of that segment. That is also true of the term diameter. First question they ask us is to name the circle. The circle has a center at E, so it is named Circle E. Grammatically, this one's a little challenged. It says name the radius of the circle. There's more than one radius. They should have said radii. All right, they redeemed themselves in the answer. The radii shown are segment EB, segment AE, segment EC, and segment ED. Now they ask us to name a chord of the circle. So if they word it that way, there are 4 different correct answers. You could either have chord AB, AC, BD, or AD. Name a diameter of the circle. Again, there's more than one. Of the ones they drew, segment AC and segment BD are the only chords that go through the center, so they are diameters. We kind of talked about this with lines of symmetry of a circle. There are an infinite number of radii in each circle. Likewise, there are an infinite number of diameters. Circle R has diameters ST and QM. If ST is 18, find RS. Well, radius is half the diameter, so R is going to equal 1/2. The diameter they said was 18, so half of 18 is 9. And yes, I know there are no units. There should be units. Okay, same beginning. We have diameters ST and QM. This time they told us that RM is 24. So if we know the radius, we want to find the diameter. To undo that 1/2 times D, we're going to multiply both sides times 2. And so we get 48 equals D. Okay, again, we have circle R, and it has diameters of ST and QM. If RN, which is 1 radius, is 2, find RP. Well, guess what? All of the radii of a circle are congruent. So if RN is 2, RP is also 2. The diameters of circle X, circle Y, and circle Z are 22 millimeters, 16 millimeters, and 10 millimeters. And they ask us to find easy. Hey, they finally gave us units. They're millimeters. We know that radius is half a diameter. So for circle X, if we take 22 divided by 2, we get 11. For circle Y, 16 divided by 2 is 8. And for circle Z, 10 divided by 2 is 5. Okay, so there's my 11. I said the radius of circle Y was 8, and so altogether that has to make 11, so that leaves 11 minus 8 leaves 3 right there. Circle Z was 5 and 5. Okay, we've got everything filled in. Find EZ. Okay, that'll be easy. Haha, haha. Okay, if we just add, we have, well, 11 plus 11 for circle X, which we knew that was 22, and then plus 5 gets us all the way from E to Z. So we get a sum of 27 millimeters. Okay, same beginning, same diameters, find XF. And we already have it labeled on the diagram, so from X to F is just going to be 8 plus 3, that's an ugly 8, is 11 millimeters. The circles shown in example 3 have different radii. They are not congruent circles. For two circles to be congruent circles, they must have congruent radii or congruent diameters. The circumference of a circle is the distance around the circle. Circumference is most often represented by the letter capital C. By definition, the ratio C over D is an irrational number called pi, symbolized by the Greek letter pi. Two formulas for circumference can be derived using this definition. So circumference divided by diameter is pi was our original definition. So if we multiply both sides by D, we get C equals pi times diameter, which is our circumference formula. Or if we replace D with 2r, because diameter equals 2 times radius, we get C equals 2 pi r. For a circumference of C units and a diameter of D units, or a radius of r units, C equals pi times diameter, or C equals 2 pi r. Find C if r equals 13 inches, so we're using our C equals 2 pi r. And in this book, they use the value of pi in a calculator, so we can just type it in the calculator to pi button times 13. Now on our fancy calculators, it will leave pi as pi, so it equals exactly 26 pi. That's exact without rounding. Or if we want to round to the nearest hundredth, it's a nice place, we would get 81.68 inches. So if they give us diameter, it's actually a step easier because we don't even have to multiply by 2. C equals pi times 6, which would equal 6 pi exactly. Or if we round to the nearest hundredth, 18.85, and we were in millimeters this time. Next they ask us to find the diameter and a radius to the nearest hundredth if the circumference is 65.4 feet. So it doesn't matter which of the two formulas I use, I just use circumference as pi times diameter. So I'm going to substitute in 65.4 for C equals pi times D. So on the calculator, I'm going to type 65.4 divided by, and then the pi button. So I get the diameter is about, rounding to the nearest hundredth it said, so I better round because it said to, 20.82 feet, and radius is half of diameter, so it would be, oops, it should still be approximately 10.41 feet. For our last question, we have one that looks like a standardized test question that could be on ACT. And they ask us to find the exact circumference of circle K. So exact means they want to leave pi as pi, which all their answers did. Now we don't know what the radius is, but we do know that all of the radii of a circle are congruent. So that makes this a 45, 45, 90 right triangle, which we remember our reference triangle, our sides went 1, 1, square root of 2. So my square root is 2 sides being multiplied by 3, so that means that these two sides must also be 3. So now that I know r, circumference equals 2 pi r, so c equals 2 pi times 3, which is exactly 6 pi, which is choice B. In summary, the diameter of a circle is twice the radius. The circumference c of a circle with diameter d or radius of r can be written in the form c equals pi times diameter or c equals 2 pi r.